special set is a well-defined portion of those ASCII characters that the regex uses for its engine uses for its own purposes to so you can give it some commands basically. An ordinary set consists of all the characters that are not special. These special characters are sometimes also called meta characters if you read about regular expressions. Now the simplest thing you can do is just match a literal string, just like in fixed string searches, where you give it a single character and it just matches the first occurrence of that character in the string. And obviously you can give it more than one character, then it just does them one after the other. If you want to match extended characters, which are not directly enterable on the keyboard, you can use the \x followed by hexadecimal digits. Use that notation, so you can say \x, E9 or something like that. And if you want to match Unicode when it's in UTF-8 mode, you can use \x and then in curly braces give it the Unicode code point. Now, these meta characters, they're nice because you can use them to give commands to the regular expression engine, but what if we actually want to match one of these characters literally, right? Well, we have to, there are a couple ways of doing it. One is you \, you escape it basically. So $sign usually means end of string, but you \, it just means $sign. If you have more than one of those characters in a piece you're trying to match, you can surround it with \q and \e. And then the whole thing between those will just be a literal match. So if you wanted to match something like that, or you can \, them as well. Just depends on how many of those you have in your regex. Now, matching literal characters is useful, but we actually want to talk about patterns, right? And one of the patterns is the character classes. It basically is a set of characters that is placed inside the square brackets, and it's going to match only one of those characters, right? So you give it an option, like if you're trying to match English vowels, A, E, I, O, U, lowercase, you put them inside the square brackets, and then when it tries to do a match, if it finds a vowel, it's going to match one of those. Or if you want to match surf or turf, right? You say either starts with S or T and followed by the literal string. If you put a caret at the beginning of the character class, it inverts it. It's basically called negated class. And it'll match any character that's not in that class, including new lines. So if you have something like not less than or greater than sign, it'll match any character that's not less than or greater than. You can put however many characters you want inside the character class, but if you just, let's say if you're trying to match all the digits or all the English or Latin characters, it'd be useful to shorten that up, right? And you can do that with character ranges, where if you put a dash between two characters, it'll create a range from the first one to the second one, and it's the same thing as listing them all explicitly. So it's a way to abbreviate it. So this would match all the lowercase Latin characters. You can reverse it to basically means the same thing. You can put more than one range in a character class, and also just add have additional symbols. So this would describe a set of characters from A to Z and digits from 0 to 9, as well as a colon character. Ranges are very useful, and it'd be nice to have some shortcuts for those, and in fact there are shortcuts. You can have \W, which means a word character, and the actual word was poorly chosen, I think, because it's actually an identifier matching, just like in programming languages. So it's uppercase and lowercase A to Z, 0 to 9, and underscore. So watch out if you say \W and it matches an underscore, it's actually possible. \D will be a decimal digit, 0 to 9. \S a white space, which consists of literal space, new line, tab, feed, and things like that. And then there are the reverse ones, where if you capitalize them, It's going to be not a word character, not a decimal digit, and not white space. Okay? Questions so far? No. If you put a meta character inside the character class, inside brackets, most of them lose their meaning. So that's another way to escape them. The exceptions are the closing bracket, the backslash, the caret, and the dash. If you want to use these ones literally, you have to either escape them by backslashing, or you put them somewhere where they don't have special meaning. So normally caret inside character class, if you put it at the beginning, means it's negated, it's right. But if you put it at the end, it's just the caret. It doesn't matter. Same with the dash. If you put it at the very end, it just means a dash. Dot meta character. By default, it matches any single character except a new line. And that just comes from Unix background where they were doing line-based matches and wanted to stop at the new line. So it's equivalent of this, not a new line. You have to use it carefully because it might match something you didn't intend to match. So if you do something like 12.45, yeah, it'll match the actual 12.45 string, but it'll also match any of these, right? Because dot means anything, including like space and whatever. So watch out for that. So when we do regular expressions, we use them because we're not sure of the contents of what we're searching for. And you can write simple regular expressions just with character classes and literals, but they become especially useful when you combine them with quantifiers. And quantifiers help us deal with this uncertainty. They specify how many times a certain component that they're applied to is supposed to repeat in order for the match to be successful. And these repeatable components that you apply quantifiers to are literal character, dot meta character, character class, dot meta character, character class, and these range shortcuts, and a couple other things that we'll talk about later, subpatterns and back references. So the first quantifier is question mark, which means 0 or 1. It basically says that the component it's applied to is optional. It may or may not occur there, and the match will be successful either way. So if you say welcome, bang with a question mark, it'll match welcome with or without the bang. Right? If you apply it to a character class, like in the last bullet, it'll match hello, hello with a bang, hello with a question mark, and all that stuff. Now the next one is plus, which means 1 or more. And it says that this component has to appear at least once. 1 to infinity, basically. So if you're trying to match the word goal with any number of O's, you can say GO plus AL, and plus means that 1 or more O's. Matching negative integers, like minus 33 or whatever, you can say minus backslash D plus, and it'll match 1 or more digits. If you apply it to this negated character class, saying not quote plus, it means match a sequence of characters until it runs into a quote, which is a useful paradigm. The next one is 0 or more, and this one means that the preceding component can match 0 or more times, 0 to infinity. So if you're trying to match floating point numbers, for example, we can do something like backslash D plus, then literal period, because otherwise it's a meta character that means anything. Backslash D, and then a star for 0 or more, and that means the floating point can have any number of digits. Or if you're trying to match an opening HTML tag, like simple ones with no attributes, you can do something like, okay, it has to start with a letter, so a character class for A to Z, and then after that it can be A to Z or digits 0 or more times, right? And it'll match like B or H2 or table or whatever, but not the closing ones, because it starts with a slash. So these are specific quantifiers, and then there's a general repetition one, where you say what is the minimum and the maximum number of times something has to repeat. So if you say HA and then put curly braces 1, 3, it means A can occur from 1 to 3 times. Or if you're trying to match exactly 8 digits rather than typing \D 8 times, you can say \D and then in curly braces just put 8. If you omit the second number, there's not going to be any upper range. So in that sense, you can replace any of these previously described quantifiers with this one, right? Because the question mark just means 0, 1. So 0, 1. Plus is from 1 to infinity, and star is 0 to infinity. You can omit the first number as well, and then it just means 0, basically. Now, greediness is an important concept to understand in the context of regular expressions, where it means match as much as possible up to a certain limit, right? So if we have something like PHP 5 question mark, the regular expression engine has a choice of whether to match that 5 or not match it, right? Because it's 0, 1. But with greediness, it'll always try to match it. Same thing with you in the second example, where if you say, okay, match 2 to 4 digits. Well, in this string, there are 2 groups of 2 digits and 1 group of 4 digits, right? And it's going to try to match the longest one, because it's greedy. It's going to try to grab as much as possible. So if you take a quantifier like plus and you say, oh, I'm just going to match HTML tags. I've seen this a number of times where people do something like, oh, open a bracket, dot, plus, close bracket. And what happens when it tries to match it is that it'll match the whole string rather than just the opening one, because dot means anything and plus means 1 or more times. So it's going to just match the opening one and run to the end and match the closing one. Not exactly what you wanted to do. And another thing about greediness is that if the entire match fails because it consumed too much, like it tried to grab too much for that specific part of a regular expression, then the engine has to give up a portion of the match, so basically go back, and in order to make the rest of the regular expression succeed. So it's not always just linear left to right. Sometimes it has to go back and retry again so that the subsequent portions can match. As an example, like if you're trying to find words that end in ness, you'll probably use something like, okay, \W plus, so any number of word characters followed by ness, right? And what happens is, on the very first run, the \W plus will match the whole word, but then it still needs to match ness, so it needs to give up 4 characters, and then \W plus matches just that portion, and then the literal ness has to match as well. And that's not always what you want, because that means extra work for a regular expression engine, right? It slows it down a bit. And you can overcome this greediness. The simplest solution is you can make the repetition operators, the quantifiers, non-greedy or lazy. And lazy quantifiers do the opposite. They try to grab as little as possible when they have a choice with match or non-match. And if the overall match fails, then they grab a little more and try matching again. It's sort of the opposite behavior from the greedy ones. To make a greedy quantifier lazy, you just append a question mark, which is completely different use of question mark than the repetition one, right? So you have star question mark, plus question mark, the general repetition mark, question mark, and the very confusing question mark, question mark. So let's see how that works, right? So if you put a question mark after the plus in the previous example, then since it grabs as little as possible, it'll match the bracket, then the I for the dot, and then the closing bracket right away. And that's what you wanted, right? Another option to overcome greediness is to use negated character classes. They're actually more efficient and more easier to understand sometimes, a little more explicit. So instead of doing like dot plus question mark, you can say match the opening bracket and then one or more characters that are not the closing bracket, and then a closing bracket, right? And then I'll just run along and match anything between the first opening one and the first closing one. But note that this version will match tags spanning multiple lines, right? Because when you say not greater, not the closing bracket, it also includes new line. So if you want to do a single line version, you have to explicitly exclude new lines as well. So do something like not bracket \r \n. Assertions and anchors. So assertion is an operator that expresses a statement. It's a test, basically, at the current matching point where the regular expression engine is right now. It does not consume any characters. It just basically evaluates the current position and provides a Boolean that you can result that you can use. And the most common type of assertion is what's called an anchor, where it anchors the match to a certain position. So caret, another double use of a character, has nothing to do with character classes in this case. It's an anchor that matches at the beginning of the string. So if you want to match letter F at the beginning of the string, you say caret F, and that has to match there. $sign is an anchor that matches at the end of the string or immediately before a new line if it's the last character in the string. And that comes from Unix, again, where they basically what we were doing line-oriented processing. So if you say \d $sign, it means the subject string has to end with a digit. Multi-line matching. So the previous ones were fine for single lines, but if your subject string has multiple lines, then it'd be useful to match the beginning and ends of line inside there. And you can do that if you set the multi-line option when you execute a regular expression. If the multi-line option is set, then caret also matches immediately after any new lines, so like at the beginning of the each line in the multi-line string, and $sign matches immediately before those new lines, so at the end. So if you have something like caret T and then dot plus, it means I want to match the letter T followed by any number of characters at the beginning of lines. So it'll match those. Oops, sorry. Yeah, match 2 and 3. And that's fine. This is really useful if you have a big text that you want to match inside. But sometimes you really want to match the very start or end of that big text. You don't care about embedded new lines. You just care about the exact start and end. And this works regardless of whether the multi-line option is turned on or off. These will always match at the very beginning. \A, \z matches at the very end. And then capital Z sort of works like the $sign, where it's at the very end or right before a new line. So in this case, if we say \A T dot plus, it'll only match the first one because that's the very beginning of the text. Word boundaries are another type of assertion or anchor. It's a position in a string where you have a word character on one side and a non-word character on the other side. Doesn't matter which, left or right or whatever. And if that statement is true, then it'll match at the current position. So if you do something like \b to \b, it means that that string has to have like space or punctuation or something on other sides. It's a useful way to do word boundaries, basically. And then there's a \B, which matches when the current position is not a word boundary. Basically, there's word characters on either side of it, of the current position. So if you were trying to do something like match digit 2 when it's surrounded by other digits or letters, you can do this to ensure that it's embedded in something. Subpatterns. So sometimes once you start building up longer regular expressions, sometimes you want to apply operators to larger portions of them, and that's where subpatterns come in. They can be used to group a part of the regex together. So if you do something like if trying to match is or island, you can do is and then put land in parentheses and put question mark after it. And then the whole land is optional. Or if you're matching something like comma-separated list of double-digit numbers, where you need to have at least one number, but the rest can be comma followed by commas and more double digits. You can do something like that, where you group the two digits and a comma together and say 0 more times, and then \D twice again. Now, by default, all the subpatterns are capturing, which means that when the match happens, the regex engine takes that match and saves it, so that you can get at it later and use it in your programming language. It stores it it numbers the subpatterns so that you know which one you can access later. And it does it by counting the opening parentheses from left to right. So if you have a regular expression where you have an outer subpattern and then embedded one, you have another one, then you have two, right? There's two opening parentheses there. So if you apply it to this one, to the string that expresses a date like that, then the second one, the embedded one, will capture the word may. And you can get at it with, in PHP at least, you say $, whatever you call your match array, $match, and then access the second element. This capturing aspect of subpatterns is useful, but not always necessary. Because A, it requires more memory, because it has to store those matches somewhere. And B, more processing time, right? It has to copy the match string into memory and then pass it to you when you execute the regular expression. You want to get at it. Sometimes you just want to use subpatterns purely for grouping. And if you use a question mark colon after the opening parentheses, then it turns off that capturing. It's just a grouping subpattern. And it also is not included in that numbering. So if you mix capturing and non-capturing ones, you have to don't count the non-capturing ones when you try to figure out what the number of the pattern is. It can be kind of tough to keep track of subpatterns once you have more than, I don't know, 3 or 4. So you can actually give them names, and they're called named subpatterns. If you put question mark capital P and then name in the brackets after the opening parentheses, you give it a name. And they're still assigned numbers internally, but so you can use either number or a name, but I don't know why you would use a number if you gave it a name. So in this case, if you're trying to match numbers, you can do opening parentheses, that's syntax, give it a name number, and then the actual regex. It'll match and capture 99 into subpattern name number. Alternation is another assertion, and it allows you to test several sub-expressions at a current point. You can give it, you have to give it at least 2, I guess, but there's no upper limit. And the branches are tried in the order from left to right until at least one succeeds. You can have an empty branch. So you can say like match nothing or this. There's a simple example. If you say sailing or cruising, it'll match either sailing or cruising. But the thing about alternation is that it has the lowest precedence of any of the other operators. So you often have to use grouping. For example, if you're trying to match sixth sense or seventh sense, you may be tempted to just say sixth or seventh followed by sense. But because its precedence is so low that the actual concatenation has higher precedence, then it's actually going to think you're trying to match the word sixth or the phrase seventh sense. So you have to group, you have to explicitly say what you're trying to, what the alternatives are. And also remember that the regular expression engine is eager. It's trying to return the match as soon as it finds one. So if you have alternation like camel or came or camera, where they sort of start with the same letters, and you apply it to a subject string camera, it'll actually match came because that's the first one that it finds in that substring. So you have to reorder them sometimes to put the most, like the longest one or the most likely one first. You can you can't apply like question mark, like optional matching to assertions, but you can have other assertions as your branches. So if you're trying to match the word, like if you're trying to match the word friend or my friend or your friend, you can say in your subpattern you can say caret, which means beginning of the string, right? Or my or your, and it'll actually do the correct thing. Okay. Yes. Yes.
You can ignore the parent and that parent is pipe, my friend, or your.
If you have, all right. So the question is, what happens if you remove the caret and it's just parentheses, empty, pipe, my pipe, your, right? It will match. It's not very useful because it'll match anything at that anywhere that friend occurs. It doesn't matter what comes before it. Yes. Yes, because it's an empty alternative. Yeah. Okay. Next topic is backtracking, which is very, very important to understand. And it basically means if you don't succeed at first, you try again. So when faced with several options where it could achieve a match, the engine picks one of them and remembers the other options for later. And then if the option it picked does not result in a successful match, it backtracks to that decision point and tries the next one. And it does it until it succeeds or fails completely. And these decision points where that happens includes anywhere you use quantifiers or anywhere you use that alternation, the pipe character. And two important rules with backtracking is that when you have greedy quantifiers that try to grab as much as possible, it will always attempt to match something first. And with the lazy ones, it'll try to delay the match as much as possible. And if there are several decision points, then it always goes back to the most recent one. So like in a stack order, basically. So there's an example of backtracking, just to understand what that actually means. Let's say we're trying to match a sequence of digits ending in double zeros, right? And we have this string here. So what happens, because we have a quantifier, that's a decision point, so it's going to remember that choice where that happens. So we start, okay, we match that \d plus matches 1, matches 2, 3, matches 0, right? And then, end of the string. But I still need to match 0, 0. So string exhausted, so it has to give up 1, 0, and then it tries again. Well, 0, 0 doesn't match, but still lacking characters. And then it gives up another 0, and then it can finally match the double 0, right? Success. Now, what happens if we try to match something like a sequence of digits followed by FF, and we have sequence of digits that's clearly not followed by FF, right? So we had 1, 2, 3, that matches. It can't match F there, right? But it's still gives up, the latest match and tries to match F there, which doesn't work. It gives up 2, it still can't match F there. And now it can't give up anymore because we said plus, because it has to match at least 1. If you said star, 0 more, it would give up 1 as well and try to match there. But then it fails. And the problem here is that it had to do all this extra work to give up and retry matching and all that stuff, right? So when disabling this backtracking behavior can be useful. Because the main goal here is to speed up these failed matches, where if you write a regular expression where you're sure that as soon as this match fails, like don't go and do any backtracking, there's a way to do that, especially when you have nested quantifiers. And the way to do that, are a couple of ways. One is called atomic grouping, and you basically take your regex that you want to make atomic, and you put it in parentheses and put question mark greater than. And then it treats that as a single atomic token. Like there won't be any backtracking inside it. It won't remember any of those states that may happen. It just tries to match it once, and if it fails, it fails. So in the previous example, if we put that \d plus in a parentheses and say question mark greater than, it'll lock up all those available digits, 1, 2, 3, right away. And if the next 2 are not FF, then it just fails right away. And these atomic groups are obviously not capturing, because you can't really do anything with them. These groups can be complex. You can put whatever other expressions you want inside. You can nest them together. But if you just have like our simple one, you could with a single quantifier, you can use possessive quantifiers, and they apply to a single repeated item. And guess what? There's another double use of a character, which is a plus. So if you append a plus to a quantifier, that makes it possessive, and it acts like that atomic matching. So \d plus plus ff is equivalent to the other one. And the other ones are obviously, star plus, question mark plus, and so on. And these are always greedy, of course, because they try to capture as much as possible right away. And now people sometimes go overboard and they're like, oh, I'll make everything possessive and atomic just so I want to speed this stuff up. But you have to remember that actually changes the semantics of matching. So for example, if you run \w plus d against ABCDF, it'll match ABCD, right? But if you make it possessive, it's not going to match anything at all, because it'll match all the word characters to the end and try to match D. And usually where it would give up, go back and try again, well, you told it not to do that, so the whole match fails. So be careful with that. Another thing we have is back references, and that's basically an alias or a reference to a capturing subpattern. And it matches whatever the one that it refers to has matched already. So if you're trying to find words that start with RE or LE and end with the same thing, you can say, okay, RE or LE, then any number of word characters, 1 or more, and then \1, which means match the same thing that the first subpattern matched. And if you want to make a reference to a named subpattern, you do question mark P equals and give it the name that you gave the earlier one. So another type of assertions is called the look-around assertion. And with this one, you test whether the characters immediately before and immediately after the current point match a given regular expression. So it's more of a complex statement. They consume no characters, they don't capture anything, they just basically an if statement. And it's look ahead and look behind. So positive look ahead tests whether the characters after the current point match this given regular expression. So you can do something like, well, match 1 or more word characters, and then if the next one is a colon, then go ahead and match the rest. Otherwise, it'll fail. And there's negative look ahead, which says tests whether the characters after the current point don't match something. So if you want to find the word fish that's not followed by ing, you can say fish, and then parentheses, question mark, bang, ing, and it'll match fish, but not fishing. It'll match fisherman. And It's difficult to do this with character classes. People may think like, oh, what if I do fish and then not I, not N, and not G? Is that going to work? It might work, but A, it'll consume more than you intended because each of those character classes actually consumes a portion of the string, whereas the test is just a test. It doesn't capture anything and consume it. And it'll also fail if the word has less than 7 characters, right? Because each of those has to be a character. So it's gonna fail in things like fished and things like that. And you can do complex stuff like fish, not followed by hook or ing. Similarly, there is a positive look behind, which tests whether characters immediately preceding the current point match something. And the caveat there is that the regular expression you put inside that has to be a fixed size. So you can't have quantifiers and things like that. But you can have alternation, like the pipes. So if you want to find the word bar only if it's preceded by foo, then you can do something like this, where if you give it that regular expression, it'll go run along and find the word bar, and then make a test to see, hey, is there a foo behind before it? If so, then it's overall successful match. And the same thing with negative look behind. Once again, it has to be a fixed size. And in this case, if you want to match the word bar only if it's not preceded by foo, then you use the question mark less than bang condition. Let's see. Conditionals, 40 minutes. Let's skip this and you can look at it in the slides, because they're a little bit complex. Okay. So I mentioned multi-line option earlier, and it's actually a way to modify how the regular expression matches are done directly in the regular expression by embedding these options there. So if you put parentheses question mark I, that enables case insensitive mode, so it doesn't care about the case of the characters from that point on. The M enables multi-line matching for the caret and $sign. The S one makes the dot meta character match the new line also, which is useful. So you don't have to explicitly say like dot and \n for your character class. The X ignores literal white space, which I'll show you why it's useful. And the capital U makes the quantifiers lazy by default, which sometimes is actually a pretty good idea, just to make everything lazy by default so that you don't run into that greediness where it consumes more than necessary. You can combine them and negate them too. You can say like, oh, turn on case insensitive and multi-line and turn off the S and things like that. At the very top level, they apply to the whole pattern, but inside subpatterns, they're localized. So you can have a portion of the expression that does case insensitive, but the rest is case sensitive. Comments, very important. So when I was working on Smarty sampling engine a long time ago, I wrote this regular expression. Don't laugh, you'll be writing stuff like this too at some point. So, right. I don't remember what I was trying to do there, right? Clearly I should have put some comments inside. And there are two ways to put comments inside. If you put question mark hash inside a subpattern, anything inside there is considered a comment. So you can do things like that. Or if you set that X option, then anything after a hash sign that's outside a character class and up to the new line is considered a comment. So you can do like multi-line, like line-by-line commenting of portions of your regular expression, which is very useful. And if you actually need to match literal like new line, you just say \n, right? Okay. So that was like the piece of regular expressions that we talked about. Now, you want to like put them together and actually do some common scenarios. So a little bit about this, like the toolkit from which you can draw these patterns. One very common thing people do is matching and validation, but they're different things. In matching, where you're trying to extract something from a string, you have to account for boundary conditions of what you're trying to find. And in validation, your boundary conditions are known. It's the whole string, right? So if you're trying to match an English word that starts with a capital letter, yeah, you can write your regular expression like, okay, A to Z, and then apostrophe dash, whatever. But be sure that you're specifying boundary conditions like \b on both sides or something. And if you're trying to validate that a string fulfills the same condition, that it's an English word starting with a capital letter, make sure you put caret and $sign on both sides so you can anchor it, right? Otherwise, if your string you're trying to validate has at least one English word that matches this one, that's going to succeed overall, right? But it may have garbage after that. So don't forget those for validation. I see it very commonly like validating form contents, where people forget to put the a caret and $sign and like, oh, make sure it's a number. And if it's like only a portion of the string is a number, hey, it matches. Where you talked about dot, just remember that it's a shortcut for not new line. May match more than you really want. Yeah, it'll consume all the other brackets in this case. Yeah, I mentioned that. So, unlimited repeats. This is a common problem when people start building more complex regular expressions, especially with nested stuff. And it has one of these patterns, right, where you have a quantifier inside and then another quantifier applied to the whole group. And what happens here is that if the initial match fails, the number of ways that where it can split the string between the quantifiers grows exponentially. And it gets even worse when the inner one has a dot, because that can match anything, right? So PCRE, which is the engine that PHP uses for regular expression stuff, it has an optimization that helps in certain cases. It also has a hard-coded limit for backtracking, so that it doesn't do it for 30 seconds or whatever. But the best way to solve this, you prevent unnecessary backtracking right away, either via atomic grouping or possessive quantifiers. So, as an example, let's say you want to match a sequence of words or spaces inside a quoted string, right? So you do something like, okay, double quote, a single quote, and then same thing on the end, and then in the middle you have a sub-pattern that says, okay, one or more word characters, or one to two spaces between them, right? So when you apply this to the string that has quotes on both sides, it matches very quickly. But if you missing the final quote, then it has to backtrack, and at every point where it backtracks, it can split it multiple ways between the inner and the outer repetitions. So it runs like 35 times slower, right? And who wants that? So what you do is you use a possessive quantifier to prevent backtracking, right? As soon as it matched the word or one or two spaces successfully, lock it up and don't let it backtrack. And then if at the very end the quote doesn't match, that's fine. It just fails right away. Okay, extracting markup. So you can use preg match all. You're familiar with that function, right? To extract things out of the text. But if you're trying to tokenize something, I like preg split better. So if I was trying to, if I have this piece of HTML and I was trying to tokenize it into the tags and the portions between the tags and so on, I'd rather write a regular expression that matches those delimiters, and then use preg split to split on those, and also capture the delimiters themselves. And then what you get back is an array with all your tokenized pieces. I'm not going to go into details of this right now, but you can look at the code when the slides are posted. Another common thing that I've seen is like, let's say you want to strip all the markup except for allowed subset, which is useful for like comments, right? You want to allow bold, italic, maybe something else in the comments, but not anything else. So strip tags, limited functionality. You can use string replace or preg replace to remove stuff multiple times. Some sort of custom processor, or sort of similar idea where you have this function called preg replace callback, and you give it your regular expression that matches things you want to remove, which in this case is basically says opening, closing, HTML tags. And then it invokes a function with a match for every match. And inside the function, we'll say, okay, the list of allowed tags is BIP, BRA, and then we look at it. We have the match array where the second entry is tag and third entry is attributes. And we just say, if it's not in the allowed tag, just return. So it replaces it with nothing. And if it's in the list of allowed tags, then we do a little bit more, processing. Maybe we'll strip away some evil attributes that may get embedded there, and then we'll reconstruct the proper tag and return that. So that's a way of using regular expressions to restrict markup. Matching numbers, integers are pretty easy. You do something like your word boundaries, \b, and then one or more digits. Floating point numbers, depending on the form that they take, either with integer part or without integer part, you can cover with that second regular expression, where you do something like word boundary, then one or more digits, or not a one boundary, because that's for matching the dot fractional one, the second form. And then one more digits in word boundary. You can actually match both integers and floating point numbers at the same time. You can either use the alternation to combine those, or get a little more complicated there. You can prepend plus or minus to this and so on. And word boundaries may not always be the right anchors to use, the right assertions. You may have to be a little more explicit about what should occur on both sides of the numbers. Matching quoted strings, that's a fun one. So a simple case is when a string doesn't have any escaped quotes inside, right? Because then you just say quote, not quote, 0 more times, quote. Or if that will match a quote that spans lines, but if you want a single line one, then make sure to exclude the new lines. However, if you actually allowing to match strings that have embedded escaped quotes, then you can do something like this with the look behind. So you have an opening quote, then you have start of a component, which is either a segment without any quotes, so not a quote one or more times, or a quote that's preceded by a backslash. Right? You say quote, and then the positive look behind that says does have a backslash before, and followed by, and you repeat this component 0 more times without backtracking, because we want to lock that up, right? And final quote. That, if somebody can tell me why it has 4 backslashes, I'll buy you a beer. Because what? Okay, that man earned a beer. Do you know what it's called? Like this thing when you see multiple backslashes? No, almost. It's called leaning toothpick syndrome. Okay, matching email addresses. No, do not try to use regular expressions to match email addresses, because the rules for match. So Jeffrey Friedel wrote Mastering Regular Expressions book, right? And the complete regex is about as long as a book page in 10-point type. He wrote a Perl program that generated a regular expression in order to actually construct it. But it's even worse than that, because you actually don't have to have a recipient in the email address. You can just say add something, and it goes to the default mailbox. You don't have to have the domain, right? You can have domains without dots. So basically, the simplest way to match it: does this string have an @ sign? It's an email address, possibly. All right, let's cover one more example here, and then if you have questions, we'll go with those. So let's say we're trying to match US or Canada style phone numbers, where you have like 3 digits, 3 digits, 4 digits, and they can be separated by dashes or dots, or it can have the grouping like with a parentheses, like you see that sometimes. So how would we do this in one regular expression? So a simple approach would be like, okay, well, I'll do 1 and then space dot or dash, and then 3 digits, possibly parentheses, and then digits, and so on. But this would make a lot of false positives, right? Because you can, what if you start with a dash, and then space, and then another dash? We don't want that. We want them to be consistent. So what you do is something like this, where we'll break it down for you. Let's see if this thing doesn't have a laser pointer, does it? Maybe not. So you anchor to the start of the string, because we're validating in this case. And then we say, we don't want to capture this one, so it's question mark colon. We just want to use it for grouping. And let's say, okay, 1, followed by a subpattern which matches either a dot or a dash. And if it had, optionally, because there's a question mark at the end. And since we only turned off the outer one, we'll remember what that separator is in the first subpattern, right? And then followed by 3 digits, which is the area code. And then there's this conditional, which we sort of skip, but it basically means, hey, did we match something in the first one? Did we match a separator? If so, go ahead and match the same separator here with \1. That's how you keep them aligned and consistent. Or if we didn't match it, try to match dot or dash again and remember it. And then you do another 3 digits, same separator as before, final 4 digits. Or if none of that matched, then try to match that second one with the parentheses and grouping. And anchor to the end of the string. So you can construct it out of pieces. So some tips. Also, don't try to do everything in regular expression. People go overboard sometimes, and they use preg match for simple strings. Sometimes string replace or string searches are faster and easier. PHP has a lot of string functions that are useful. Make sure you know how backtracking works. I showed you a couple of examples, but just experiment with some of that stuff and see how the atomic grouping helps you, or in your case, whether it helps or not. Be aware of the context, like what the word boundaries may be for your matches and things like that. Also capture only what you intend to use, so you don't have an regular expression edge and do extra work. Don't use single character classes, because I see people do like open square bracket, a, close bracket. You can just use a, like you don't need to put that inside a character class, unless you intend to use actually use them for capturing or things like that. Lazy versus greedy. Be specific what type of matching you want. And when you use alternation, put the most likely one or longest one first. So think about what you're trying to match. There are plenty of regular expression tools out there that help you write regular expressions and test them and debug them and whatever. I'm not going to go through them all, but I listed some here that you can check out. So with that, any questions?